Okay, we'll go ahead and start. This is a direct instruction. Specifically, we're going to be working with some normal distributions this week. Now, the first item we'll take a look at is control charts. And let me get it up here. This talks about how to make a control chart for the random variable x. Find a mean, standard deviation, tells you a little bit about that. Create a graph, draw horizontal lines, so forth. Okay. We're going to take a look at how to do it in Excel. So let's say I got my my time here, whatever that might represent. I'll just put 1 through 10. Maybe that might be weeks 1 through 10. And then I'll put my prices. Let's see, 11.23, 7.89, 5.32, 12.51, 13.82, 15.01, 11.11, 9.11, 3.56, and 20.12. There we go. Okay, now we need our mean. So I come down here. We also need our standard deviation. Now over here, specifically let's talk about mu and sigma. So population. So here I'm going to say equals average, beginning parentheses, and then I'll put my range of values here. So B2 to B11 is where I got my data. In standard deviation, I'll do equals, and then standard deviation dot P for population. And then I'm going to choose B2 to B11 again. Okay, and I got those values. Now I'm going to create a, if I just looked at this right here, if I highlight that data and choose insert, line, and then choose the first one, then it gives us this this graph right here. Let me delete that. What we want is we want mu here. We want mu minus 1 standard deviation. We want mu plus 1 standard deviation. Well, actually, I don't think they want 1 standard deviation now that I'm saying that. Okay, it says 2 standard deviations and 3 standard deviations. Okay, let's back up. This is going to be mu minus 2 standard deviations. This will be mu plus 2 standard deviations. This will be mu minus 3 standard deviations, and this will be mu plus 3 standard deviations. Now, first off on the mu here, I'm going to do an equals. And where I got my mean at is in C14. But I'm going to put a $C, $14. The dollar signs refers to an absolute referencing. So if I press enter then, now if I fill this down, they'll all be the same. If I click any one of these, you can see the formula is C14. By putting the dollar signs, when you fill it down, it will not automatically adjust the row. Now mu minus 2 standard deviations. So I'm going to do an equals, and I'm going to do $. Mu is C14. So $C, $14, minus 2 times, and then standard deviation, which is located in C15. Again, notice the use of the dollar signs for the absolute referencing. And fill that down. Now here, I'm going to do mu equals $C, $14, plus 2 times my standard deviation, which is $C, $15. So it looks like that. redoing my computer room here, and part of my monitor is up here and part of it's down here. I haven't got everything hooked into my big monitor yet, so if you're wondering why is he looking up in the sky, that's the reason why. Eventually I'll get it fixed. And then I'll fill that down. And then move -3 standard deviations and do equals $C $14 -3 times standard deviation, which is $C $15, like that. I'll fill that down. And mu +3 standard deviations, so that's equals mu, which is C14, plus 3 times $C $15. So that's our mu +3 standard deviations, and then press enter. And fill that down. Okay, now the nice part about this is, the way I've designed this is I can change values in here. Like if I change that to 14.1, and everything's automatically adjusted. So nothing's hard-coded on that with that design. I can change these numbers, and it automatically fixes that. Now, if I highlight, starting with my values, prices, excluding time, and going over to mu +3 standard deviations. Now if I do my insert and choose line and choose this option, then you're going to see this middle one here is our mu. This is mu -2 standard deviations. This is mu +2 standard deviations. This is mu -3 standard deviations. This is mu +3 standard deviations. Now, the textbook will go over how to interpret a control chart and everything, but that's how you create it. Now, if I come over here and change something, like I change 5.32 to 9.18, you see that I automatically even adjust my graph. Now, if I look at my series here, and you can right or you can left mouse click this, left mouse click again chooses that individual one, although I don't think it matters where you choose it. And if you choose select data, see, like if I have just that chose, if I choose select data, it takes me to the same place. You see series 1, you see this middle one, series 2 is our mu. So here I can do an edit on the legend entries, and I can type mean. Now the green is series 3. I can edit that, and I can say mean -2 standard deviations. And what's that, purple? I think it is series 4. And I can do an edit, and I can do mean +2 standard deviations. You know, this all depends on what version of Excel you have, of course. Blue, that's this one here. And this is mean -3 standard deviations. And series 6, I did 2 standard deviations instead of 3. I'll go back and correct that. Mean +3 standard deviations. Okay. Let me change that. That's nice. Let's try it again. Mean -3 standard deviations. There we go. You could even change series 1 for your prices, or whatever you might be dealing with. Now you can put legends on here, you can put chart titles and so forth, but that shows you how to put horizontal lines for your control chart. Okay. Now, just generally, when we're talking about a normal distribution, let me bring up my tablet. We've got our normal distribution here. It's bell-shaped. It's symmetric. The book will go over a little bit more detail. What does a normal distribution mean exactly? We'll be talking about probability. Now, probability equates directly with area. So if you run across a problem that says find the area, or it says find a probability, or it could even say proportion, then they're talking about finding the area within this graph. So you might be finding the area from here to here. So you might be finding that right there. You'll see the term at various places where it refers to standard normal. If it refers to standard normal, that indicates that your mean is equal to 0 and your standard deviation is equal to 1. Now remember, your mean, this is mu, the Greek symbol, and this is sigma, lowercase sigma, and that's 1. Now, if they don't say standard normal, there's some problems that actually say, talk about a z value. If they're referring to the z, they're also indicating that your mean is 0 and your standard deviation is 1. So that's a given on any of these problems you're taking a look at. Now, this standard normal distribution helps us to figure out how spread out our data is. For example, exactly in the middle here is mu. And this is mu minus 1 standard deviation. And this is mu plus 1 standard deviation. This is mu minus 2 standard deviations. And this is mu minus 3 standard deviations. And over here is mu plus 2 standard deviations. And here is mu plus 3 standard deviations. So that's kind of your setup. And remember, over when we're creating the control chart, we were looking at the mean minus 3 standard deviations and 2 standard deviations, and plus 2 and 3 standard deviations. So these are the ones we were focusing on. There's a reason why at least the mu plus 2 standard deviations is so important. The mu plus or minus 3 standard deviations isn't as important. Now here's how our percentages work out. Now this picture here, the m should say have the mu, the u with an extra line, but where I got this from had m there instead. So this you see is mu minus 1 standard deviation. This is mu plus 1 standard deviation, and you see that 68% of our data fall within 1 standard deviation. Over here is mu minus 2 standard deviations, and here's mu plus 2 standard deviations, and you see it says 95% fall within 2 standard deviations. And then here's mu minus 3 standard deviations, and here's mu plus 3 standard deviations, and it says 99.7% of data fall within 3 standard deviations. Now, the 95% is kind of the magic number. Oh, and by the way, you'll have some problems in the assignment that deal with this. They'll ask you what percentage, what proportion, what area, what probability falls between 1 standard deviation, 2 standard deviations. So you just simply add together all the percentages in between them. So nothing too challenging there. 95% is the magic number. Let me clear this off. And let's talk about that magic number. Yep, helps if I'm on the right keyboard. There we go. 95%. I always give this example in my regular class. I tell them nobody in the class is studying to get 100% on the test. Some of them look at me kind of strange that, it's like, well, yeah, I'm studying to get 100%. Guaranteed 100%. Think about what that would entail. Well, it might mean that you'd read the chapter a couple times before you come to class. You come to class, you be sure to ask a lot of questions if you don't understand anything. You get home, you not only do the homework as assigned, you do every problem. You maybe even get an additional stats book, and you do problems out of it. You read the chapter again after you get home, just make sure you understand it. You go see tutors. 100% is oftentimes costly in real life. We can't afford that. Nobody has that kind of time. So what we shoot for is we shoot for 95% on a test. That does not mean that we won't get 100%, but 95% is what we're aiming for. So again, that's the magic number that we're looking for. When you're talking about is something usual, they're talking about this 95%. They're asking, is your data between your mean minus 2 standard deviations to 2 mu plus 2 standard deviations? So for example, if my average age was 20 and sigma is equal to 5, the normal age, the usual age, we plug these numbers in, so I got 20 minus 2 times 5, and that's going to 20 plus 2 times 5. 2 times 5 is 10, 20 minus 10 is 10, and this is 30. So this is the normal range of values. Normal doesn't mean good or bad, just means where does everybody fall. And 95% of our data, if it follows a normal distribution, is within this range. So if it asked you if an age, let's say x equals 40, that asks you if this is usual or unusual, well, this would be unusual. Usual falls between 10 to 30. Okay, let me clear that off. And let's take a look at our normal distributions. So normal probability distributions. And these are ones dealing with probability. If you're finding a probability, other words for probability is proportion. Area is also another word, or even unusual would be that. Even if it asks for percentile. No, wait a minute. Percentile doesn't fall in this category. That's the next one. That's finding value. Okay, so if it asks for probability, percentage, proportion, area, those are all keywords that would tell us to use these formulas. Now you got a less than or equal to, greater than or equal to, or between two values. You just got 3 cases. So let's come over here and say the mean average ages is 20 with a standard deviation of 2. And we're trying to find a probability that these ages, pick one person out, and probability that their age is less than 18.5. Now here's 18.5. Less than would be shaded this way. So it'd be going this way. Now you might come over here and look at this and say, well, there's no less than. That's a less than or equal to. It really doesn't matter if you put a less than or less than or equal to, it gives you the same result. If you think about it, the age of somebody being 18.5. From a realistic standpoint, what's the probability you're going to pick somebody out and their age is exactly 18.5? Almost non-existent. 18.5 years. Well, if you broke it down to the decimal standpoint, they wouldn't be 18.5. They might be 18.52 or 521 or 3 or 7, 8. You can keep going breaking it down to finer divisions. If you think of how many possibilities are between, for example, 18 and 19 years old, decimal-wise, it's an infinite number. So the fact that they're born exactly on 18.5 is non-existent. Even from a graphical standpoint, if I think of area, if you remember area from geometry, how much is area in a line? Well, If it has a width of 2 and a height of 10, the area would equal to 2 times 10 or 20. But if it was a width of 2, it wouldn't be a line, it'd be a rectangle. By definition, a line doesn't have any width, so it doesn't have any dimension. So it doesn't occupy any space. So just a long explanation to say if it's less than or equal to, it's the same thing. Okay, so I'm coming over here, and this tells us we're going to do normal. This is our A here, so that's our A. And this tells us we're going to do normal distribution, and then we'll put in our A, which is 18.5, and then our mean, which is 20, our standard deviation, which is true, or 2, and then true. So let's see what that looks like. So equals norm dist, let's see, 18.5, 20 to true. And that gives us our answer. What does that mean exactly? That means if we pick one person out at random, the probability, the percentage chance that the person is less than 18.5 is 0.2267 or 22.66%. So it helps us give us a measure of what's the chances that we're going to pick somebody out that's less than 18.5. Okay. Now that was our less than case. So let's talk about our greater than case. Let's say our mean is still 20, and sigma is equal to 2. And then we're talking about what's probability that their age is greater than 21. Now if I draw my picture, there's 21, greater than is shaded this way. If I come over here, here's the greater than, so it's the second one. So we need to identify our A. This is our A, and it tells us we're going to use 1 minus norm dist, and then we'll put in our A, and then our mean, standard deviation, and then true. So A is 21, our mean, which is 20, our standard deviation, which is 2, and then true. So let's go see what that gives us. Okay, equals 1 minus norm dist, 21, 22, and then true. And that gives us our answer. Now if we had the between case, so mu is 20, and standard deviation is 2. And looking at the probability of the age is between 20 to 21. Actually, let me change that. Let's say that's between 19.5 and 21. There we go. Now picture-wise, never hurts to draw the picture. 19.5 and 21. We're trying to find this. And again, that's probability, but that's also area. Now this is going to be our A, and this is going to be our B. So between two values is our third choice here. You see it's equals norm dist, B, mean, standard deviation, true. So we're going to have norm dist, B, which is 21, our mean, which is 22, and true. I'll make sure you put a closing parentheses there, minus norm dist. And you see we got A, mean, standard deviation, true. So A is 19.5, and then 20, and then 2, and then true. So that's how we'd plug that in order to find the probability. So I got norm dist, and then 21, 22 true, minus norm dist 19.5, 20, 2, and true. And that give us our answer. Like I indicated, some of these will refer to standard normal. So if they say that it's standard normal, and they're asking you to find the area to the left of 2.3. Well, this is the first case. If I think of this right here, since I'm talking about standard normal, they're giving us the z is equal to 2.3, and to the left is this right here. And that's their first case here. So I won't plug this actually in the calculator, but this will be norm dist 2.3, comma, our mean for standard normal is always 0, and our standard deviation for standard normal is always 1. And then we'll put in true. Actually, maybe I will put that in. Okay, equals norm dist 2.3, 0, 1, true. And we get this value here. Now there's also 2.3. There's a norm dot sdist. That's right here. And then it asks me for z, which I could put in 2.3 and then true for cumulative. And it gives me the same value. So it puts in the 0 for the mean and standard deviation for you. I don't really use it that much, that's why I'm not very familiar with that. You see, this is how the function looks versus this right here. I don't think it's that hard to put 0 and 1 in, so I tend to just use that function on the calculator. Now that's finding our probability. Again, remembering standard normal means your mean is 0 and standard deviation is 1, even though they don't give it to you. Now finding the values. This says we're going to equals norm.inv, the probability, comma the mean, comma the standard deviation. Now this is may have to do a little bit of adjusting on this when you work it. The probability refers to the probability, the area to the left. So, on a problem, let me clear these off. Some of the problems will give you talk about percentages. Here's one in the homework I'm seeing that says find z such that 10% of the standard normal curve lies to the right of z. We'll eventually talk about standard normal curve, but they'll give you percents. So if they did tell us that the percent to the right was 20%, what they're giving us is they're giving us this right here. Let's say our mean is still 20 and our standard deviation is still 2. Now this all adds up to 100%. So if this is 20%, then this will be 80%. Because again, it all has to add up to 100%. And this is the value we're trying to find. So this was where we'll use the norm INV. You put in the probability, the area to the left. Well, the area left of this is 80%. And then you put in our mean, which is 20. And our standard deviation, which is 2. And I think what's true also. Let me see. I didn't write it here. Okay. Let me double check that in Excel. Equals norm.inv probability, which is 0.8, 20 to, okay, there's no true on that, so that's how we'd enter it. And that gives us our value. So we get 21 point, take it 2 decimal places for this example, 21.68. So the age separates the bottom 80% from the top 20% is 21.68. Now in some cases, they may give you the 20%, the area to the right. In some places they may give you the area to the left. They may tell you this is 10% over here. Well, if that's 10%, then this will be 90%. Not that you need that. This is what we're trying to find. And so we'd use norm INV, and then the area to the left. Here's our value we're trying to find. The area left of it is 10%. And then our mean, and then our standard deviation. And that's how you'd enter it in. Now in some problems, they'll give you the area in the middle. So they may tell you 95% in the middle. And we're trying to find these two values to separate them, the middle 95% from the rest. Well, if that's 95%, then we have 5% we split up into our tails. So this will be 0.025, and this will be 0.025. Now for this value, we're going to equals norm INV, our area to the left. Here's the value we're trying to find. The area to the left of it is 0.025. And then 20, and then 2. Now for this one, it's equals norm INV. Now the area left of this value. Here's this value. So the area to the left will be both of these added together. 0.025 plus 0.95 gives us 0.975. And then we put in 20, and then we put in 2. And that gives us our value. So that's how you're how you do it when you're given a value in the middle. If it says standard normal, again, standard normal means your mean is 0 and your standard deviation is 1. Again, I think there's a norm.s.inv in Excel. Let's see if that's true statement. Equals norm.s.inv. Here it is. Or if you choose that, then you see it even says has a mean of 0 and a standard deviation of 1. You have less parameters to plug in there. Okay, so now we talked a little bit about that. Let's talk about the central limit theorem and the one versus many concept. Okay. We're going to find the probability. We're going to have 1 whatever and we're going to have many whatever. Now, if we're talking about 1 whatever, then we're going to use norm dist, and this is based upon our tables back here. And then we'll have our, and I'll just put down this case here. It applies across the board though. We have your A, we have our mean, we have our standard deviation. We have our standard deviation divided by the square root. Let's try it again. Standard deviation, and then true. That's just what we had over here. Now in this one though, we're going to have norm.dist, and we'll have A, we'll have mu, but we'll have sigma divided by a square root of n. And then this will be true. So that's the difference on those. Now, one whatever versus many whatevers. What does that mean? Well, if I'm looking at a problem, I have to ask myself, they're asking me for the probability. Are they talking about one whatever or many whatevers? For example, they might ask, what's the probability you pick one person out and their age is greater than 30? Or the problem might be worded, what's the probability that out of a sample of 10 people, their average age is greater than 30? So there we're talking about 10 people. So we're talking about many people or many whatevers. So that's where we'd use this formula here. Some of the problems I'm looking at in the assignment, they'll refer to a single individual. If it doesn't say in, then you can assume it's a single whatever. Let's see. Here's a problem that says a local band is going on a U.S. summer tour, and they average about 2,000 people per concert with a standard deviation of about 400. Sounds like mean and standard deviation. Assume that these concert numbers follow a normal distribution. And then it says if a concert, so we're talking about one concert is picked. So that would be one concert or one whatever. So that's an example. I don't see any right here in this document. Of course, I guess it'd help if I... There. Then later on, they talk about a sample. They give the mean, they give the standard deviation, and then say, based upon a sample of this many people, then describe what would be the probability that is greater than this or less than this. I won't read it exactly off the assignment, but you'll be able to spot it. Okay. Let's say that we're talking about 20 books. Now we're trying to find a probability that their average number of pages is greater than 100. And let's say the mean is normally 95 and the standard deviation is equal to 5. Now, since we're talking about many whatevers, specifically many books or 20 books, that's where we'd use this formula on the right side. So we'd have norm dist. Let's try it again. Draw the picture. Okay, so we got x bar is greater than 100, shading to the right. And this from our PowerPoint, we know shading to the right is 1 minus. So this is going to be 1 minus, and then this. So norm dist, and then we put in 100, comma, our mean, which is 95, comma, our standard deviation, which is 5, divided by the square root of n, so divided by the square root of 20. And then true. And that would give us our value. Now the idea of the central limit theorem is that instead of looking at single individuals, we're looking at multiple individuals, many individuals, or many whatever we're talking about. They don't have to be people. They can be books, as you see. And by looking at a sample, we're going to exclude some of the extreme values that will occur. And it'll give us a better idea of where does everything fall normally. Now, the same idea holds true when we're asked to find a value. I don't think there's any problems dealing with this, but if they're asking you to find a value, you again have the option of 1 whatever, or you'll have the option of many whatever. This is based upon this formula here, where probability is the area to the left. So if you got 1 whatever, you're going to have norm I and V, the area to the left, and then your mean, and then your standard deviation. Now if you're talking about many, like you got a sample of 20 books, for example, then you're going to use norm I and V, area to the left, your mean, and then your standard deviation divided by the square root of n. So same idea, we just take the standard deviation divided by the square root of n. Okay, now let me talk about some more ideas you may run across while doing the assignment. Obviously, I'm not covering the entire material. You got the material you can read out of the chapter, see the examples and so forth. But if I'm using the tables in the book, they have a formula that z is equal to x minus mu over sigma. Now, some of the problems you'll have to use this formula. Not to find a probability. You can just use your Excel functions to do that. But they may ask you maybe who did better on a test, for example. Is one I'm looking at that follows that. And by changing them to a z-score, you can then compare the z-scores. You can also, if it asks you to find a z, then you can use this formula in some cases. Here's one I'm looking at that gives you the mean, gives you standard deviation, then they want you to find the z-score corresponding to something. So it's not hard. If you given x is equal to 20, sigma is equal to 19, or mu is equal to 19, sorry. Sigma is equal to 2. You just plug those in. So we'll have 20 minus 19 divided by 2. 20 minus 19 is 1, so we got 1/2, or z is equal to 0.5. Now the z's, whenever we're referring to those refer to how many standard deviations it varies from the mean. So remember our graph. Here's mu. Here is mu plus 1 standard deviation, and here is mu plus 2 standard deviations. When we're talking about 0.5, well, here's 1 standard deviation, so half a standard deviation would be right here. So that talks about how much this varies from the middle when we're talking about our standardization, or normal standardization. Now, as you're working through these problems in assignment, if you're stuck, don't sit there and leave it blank. Go find ones out in the material, not in assignments. I won't work those, but if you find similar problems out in the assignment, out on the website, and I'm talking about the non-graded, the Applia, or I can never remember the name of that additional site. But if you go out there and you find problems, email me. Say, hey, can you work this using Excel, or can you just work this problem? And I'll work it in the YouTube video and send it back to you. So don't feel like you're left out on your own and you have no place to ask questions. Also, don't forget, I have my online office hours. So You can get online then and ask me any questions you want, except for I won't answer any off the assignment here. That's graded, but anything off the non-graded assignment, I'll help you in any way on those problems. Now, a lot of the rest of this is based upon definitions and so forth, and that just you get from the reading. But I wanted to show you some of the more difficult components, and also the technology piece. How do you plug it into Excel? Now I'm going to go ahead and stop the recording, and then I'll answer any questions you have.